Okay, so C structures, what I want to talk about, they're used to group information that belongs together. The quintessential example is the tuple, coordinates that define a point. So an n tuple would be an n coordinate, a two tuple or a double is, x, y coordinates to define a point. So they belong together, like the x and the y, they're grouped. Like if you have the x, you want to go with the y, right? The following example shows some of the syntax. So here's a main that defines a struct, and we call it a point struct. Now, this is optional. We don't have to name it. It's called a tag if we name it. But it's kind of nice if we do name it. Then whenever we define different instantiations of it, we don't have to rewrite the whole struct thing. So if we call it point, we can just use struct point later on to define a point. So struct point, it's going to have a double we'll call x and a double we'll call y. And if we declare pt1, so point 1, to be a struct point, then we can actually either declare it without an initializing value, or we can initialize it either way. So I did one where I initialized it, the other one I did not. And for point 2, I'm going to assign to it that it be point 1's x coordinate multiplied by 2. And that's how you access the x from point 1. And that's how you access the y from point 1.
2.4 become 2.4.
Yeah, exactly. So x should be 2 times 1.2, which is 2.4. And if I print it out, what should I do? I printed it out here. We get 2.4. And then 3 times 4.5 is 13.5.
So get there? In point 1, how does it know that 1.2 is x, 4.5 is y?
Because when we declared it, we initialized it, right? So right here, oh, and it's the order. So as far as which is which, is that what your question was?
So yeah, so when you say like double x, that means that's going to be the first one?
Yeah. Then when you initialize, you have to use that same order. Or you could explicitly say point to dot x equals, and then that would be more explicit.
I have one question about
Yeah.
this initializing.
Mm-hmm.
In the previous lab, like and is if we just declare it and initialize it at that line,
Mm-hmm.
is it different from when we declare it just a sole variable and then we assign it to 0 or something like this? Which one?
Yeah, so you can do either. You can't get anything useful from point 2 until you've actually assigned to it, right? So point 1 we assigned when we declared, but we didn't assign to point 2. So that's why down here we assigned to point 2. And then we'll ask for point 2
But
later.
I mean, if we do it differently, like the point 1,
Mm-hmm.
we just declare the struct point 1 and we semicolon and then we just point 1 equal to.
Yeah, so we can overwrite it. Is that your question? So I could say right here, I could say point 1 dot x equals 17, and I would overwrite 1.2. So you can do that. So you can, and when you declare it, you can either initialize it to some value, and you could overwrite that later if you wanted to, or you could keep it. It's a variable, so you're allowed to change it. Yeah, so that's like the basic syntax of the struct. So this is sort of some of the terminology. Structure tag is what we called the point. Point is what we called it. So this is called the structure tag. And then point 1 and point 2 are two instances of the structure point. Yeah. Oh, also, I made both of the two members doubles, but they needn't have been doubles. One could have been an int, or one could have been a char. It doesn't matter. You can have different types that are grouped together in a struct. Similar to in MATLAB, when you had a struct, you could use different data types in that.
But when we declare this type, when we write like s, for example, 1.2 s, but we declare the double, it will just give us error, right?
Yeah, it'll probably give you a compile error. You'll be assigning. I mean, it might. So I don't know if it'll give you a compiler error or if it will just cast it.
And make it
Some I don't know in this particular case. It kind of depends on the compiler, I think.
If you make like, say, multiple structs in a function,
Mm-hmm.
and you want to call those, like, so for point, would it be point.pt1.x? You're calling like that individual.
So if you wanted to just use it in an expression later, or
Yeah, like if you wanted to just bring out like one of the elements.
so you mean like return it?
Yeah.
Yeah. So then you would just say like point.x. So you would say I didn't return anything, but I could have written like return, and then you could use like point1.x, and it would just return that. And in fact, you can return an entire struct as well. So you could return pt1 as well.
So you don't have to do like point.pt1.
No, so point is only used when you're declaring it. You don't have to say it again anymore. So, yeah.
I have a question about this return. If we return point 1, what type of the return is it? Is it this array or?
It's a struct. So you would, I think maybe this is what Dan was getting at too. Well, you can't do it for your main because your main has to be an int. But if it was in another function, what would you write here in your prototype? You would write struct. And I think it's okay if you just write struct. It's better to be specific though and use point as well if you're going to be returning like pt1. That just gives you, it's easier to read what it is that's coming out of the function. So an instance of a structure can be assigned at declaration, like we did, or after, as we did with point 2. The members of an instance are accessed and written to via the name defined in the initial declaration. So point2.x and point2.y are the names given. C structures can also be nested. For instance, a line segment can be defined by 2 points, as shown in the following snippet, which could be interpolated into the previous main function, but I just read it separately. So struct segment, so I have a new segment tag, or a new struct tag called segment. And it consists of 2 point structures, okay? And I also initialized a variable seg1 to be a line segment, a segment struct. So then I say seg1, and I called it pt1 inside there, and I said it's equal to pt1. Notice that I use this, so pt1, I'm using it from the previous main function, right? I'm using pt1 as if it was part of the same function. So pt1 is a variable in the namespace, regular struct, point struct, and .pt1 is also the name of a member of a line segment. Because there is never ambiguity, it always is clear from context which you're using. You can use the same name as a member of a struct and as a variable in your space, and they never, because this one always shows up with a dot after something else, so you never have to worry about them being confused. So, and in fact, it's, I think, generally considered to be advantageous to use this to your advantage. Like PT1, assign it to PT1 inside there, just so that you keep it clear, right? So that you're not like, oh, it's P1 inside here and it's PT1 outside there. It's kind of nice to use the same name.
Is this struct things is another use beside array?
You can use it in place of an array in certain cases, yeah. So it's generally not as efficient to use for numerical things. So I wouldn't use it if you just have numerical data. But it's especially useful if you're going to have something that's like a database-like pieces of information, like yeah, like name, address, that type of thing works really well for a struct without going to a full database, right? Like, I mean, at some point, if it gets large and you have a lot of different, I guess, members of your struct, you might want to consider any big data that you're working with. You might want to consider using an actual database and interacting with it. But if it's small enough to write into your program the data that you need, like in the case that we used in the lab was, like we had a table that was defined as a two-dimensional array, right? We could do that with like row and column and each key. We could have defined it as a struct as well. So that would be fine. I wouldn't go totally big and like put some huge piece of data into, or a huge grouping of data into a struct. But it works for sort of smaller data sets. And you can access things like you access the nested thing. So segment 1, point 1, the x coordinate, segment 1, point 1, y coordinate, segment 1, point 2, x coordinate, etc. You can access it like that, which is very natural to do with certain types of data. So it works nicely. Note that we can overload the names. So I said that like point 1 and x without conflict. Furthermore, the syntax that declares seg1 can be used to declare further segments. So I used, notice this time when I defined the struct, after the last brace, I put seg1. I could have also written another line that said struct segment seg1 or seg2 or seg3 or whatever. But you can do, just like with int, you can just list a bunch of them afterwards. You don't have to have just one per line. You can do the same thing. You could put like another seg1. You could put like seg2 and space seg3, etc. So you do that too. Good. So a function can be passed. So a function can be passed as an argument, a struct, or a pointer to it, or each of its members separately. So you can do any of those options. Similarly, a function can return structures in any of these ways. So it can either return the entire structure, can return a pointer to the structure, or it can return some member of the structure. All of those are acceptable. Note that structure tags declared in main are available in other functions. So if you had some sub-function in main, then the struct point would be available in that sub-function. So that's important to note. And that's that's got to be the case, right? Because you don't want to get to some lower level function and suddenly have an object you don't recognize, right? Like you have to be able to recognize what that object is. That's sort of a global declaration because you can't use a data type in one part of your program and then have it hand it to another part of the program that doesn't recognize it at all. So it's available at the lower levels. So, okay, that was all the guidance I had. Did you guys have any questions? I mean, we're doing like some pretty cool stuff this week. I think that like getting tricky with the keypad algorithm is fun, and then using that logic to determine which row and which column. It's just kind of we're sort of using the very basics of Boolean logic, like true, false. Like if this is true, then this. It's pretty. I think it's a cool lab. This is the last of the like strongly I/O keypad and well, we have a lot of I/O in this class, but this is the last of the keypad LCD focus of the course, and then we're going to move on. And so this one I'm having due next Monday. I am going to have us. Then we'll have 2 weeks to do Lab 4, which I think is good because we're switching gears a little bit. There's a little bit of theory to go back and cover. So, yeah.
What is the lab for about?
It's finite state machines. So.
Is that the pulse modulation one?
I think that's 2 from now. Yeah. Yeah. Okay. Cool. Good deal.